All right, so for Unit 6, there are many situations in science, engineering, and other fields where a process is governed by repeatedly multiplying or dividing by the same quantity. Repeated multiplication and division is represented by exponents. So we've worked with these already, but let's review some basics in the first exercise. So if each of the following problems involve basic exponent ideas, answer each to review your previous knowledge. So if you want to do these all on your own and then pause and then check to see if you did them correct, that would probably be the best way to make sure that you truly understand. So letter A says, represent 6 to the third power as an extended product, but don't evaluate, so don't actually give the answer. So all they're looking for is 6 times itself 3 times. But let's look at letter B. If f of x equals 2 times x to the third power plus 7, then f of negative 1 equals. That equal sign means you really have to actually evaluate the product or give an answer. So, sorry about that. So 2 times negative 1 to the third power plus 7. So first we have to evaluate what is negative 1 to the third power. Well, that's negative 1 times negative 1 times negative 1, which stays negative 1. 2 times negative 1 is negative 2. Negative 2 plus 7 equals 5. So letter C. If x to the third power times x to the fifth power is written in the form of x to the n power, what is the value of n? So it's saying if you were to combine them all in whatever way that we are to do this, what would the final product be? So remember, so x to the third power is times itself 3 times. X to the fifth power is times itself 5 times. So really what you're doing is you're adding them. It becomes x to the third plus fifth, which is x to the eighth power. And if you went and counted, there are 1, 2, 3, 4, 5, 6, 7, 8 x's there. So in this expression, it's written in the form ax to the b. What is the value of a plus b? So we have 5x cubed to the second power. So really, we have to square 5, which is 25. And then remember that when they are raised power of a power, you actually multiply them. So it becomes x to the sixth. But it's saying, if this is a and this is b, and I add them, I get 31. This really isn't anything specific you need to know, but it's just you need to start understanding how to manipulate numbers to get different products, sums, differences, and so on. If the length of a rectangle, so let's look at a rectangle. If the length of the rectangle is 3 times 10 to the fifth power, and the width is 2 times 10 to the fourth power, what's its area? Well, remember, area means I'm going to multiply them together. So I have 2 times 3, which is 6. And it's always times 10 because our base number system is 10. And then when we multiply numbers that have the same base, we actually add the exponents, so it becomes 9. And this is meters squared because we found the area. All right, finally, rewrite the product as an equivalent expression in simplest exponential form. So the first one, we have to square this, so it becomes 9x to the fourth. And we're still multiplying it by cubing this, which becomes 8x to the 15th. So now 9 times 8 is 72, and x to the fourth and x to the 15th becomes x to the 19th. We would also like to be able to write simpler equivalent expressions involving ratios or division problems involving exponents. This all comes down to the ability to unmultiply the fractions. So let's look at exercise number 2. So first thing we want to do is write this expression as product of 2 fractions, one of which is equal to 1. So if I have 2 over 2, right, because that's equal to 1, to get 2 over 4, the second one is going to have 2 on the bottom also, right? Because 2 times nothing on the top would be 2, and 2 times 2 on the bottom becomes 4. And then I have x to, sorry, I'm going to do this. X to the 6th on top and x to the 2nd on bottom. But remember, in order for the first fraction to equal 1, we have to have the same thing on the top that we do on the bottom. So the smallest number we have on the top or bottom is 2. So now I have 2x squared on top, 2x squared on bottom. And in my second fraction, I just have 2 on the bottom, so what's left over is x to the 4th. So this is the equivalent. As if I were to multiply across the top, 2 times x squared times x to the 4th becomes 2x to the 6th, and 2 times x squared times 2 becomes 4x squared. So now we're going to simplify the expression. So obviously, if I have 2x squared over 2x squared, and I have x to the 4th over 2, is it true that this becomes 1? And all that we are left with is x to the 4th over 2. Yeah, it is. So that is simplified. So we want to start doing these a little bit more quickly. So let's rewrite these expressions as a product of two fractions, one of which is equal to 1. So the first one, I have to have 5 over 5, and let's do the simplest one. So 5 to the 3rd over 5 to the 3rd, and what's left over is 5 to the 4th. So obviously this is gone, and 5 to the 4th is your answer. Next one, I have x to the 4th over x to the 4th. What's left over is 1 over x to the 6th. So this is gone, so 1 over x to the 6th is your answer. Next one, I have the minimum of 1x on both the top and the bottom, and the minimum of y to the 8th on the top and the bottom. And what we have left over is x to the 3rd and y squared. So obviously this is gone, and x to the 3rd and y squared is what's left. So now let's simplify some more complicated exponential expressions. Each time we go back to rewriting the expressions based on the basic principles. So here's what I'm going to do. I'm going to show you another way to do them. First, we're going to go ahead and simplify any that can be simplified. So this one, the numerator can be simplified. 3 to the 3rd power is 27. And remember, when we have power of a power, you multiply those. So what we're going to do first is we look at the numbers, the coefficients that are not related to the exponents. So 27 and 9. This is still a division problem. You divide like you would divide in any other time. So 27 divided by 9 is 3. Because the 27 is larger, it stays in the numerator. Then we look at the x's. Is x bigger in top or bottom? Well, the x is bigger in top, so it stays in the top. And remember, when you are dividing exponents, you're really subtracting. So 6 minus 4 becomes 2. We don't have anything left in the denominator, so you could put it as over 1, or you could just keep it as 3x squared. All right, so we're going to simplify both of these first. 5 squared is 25. X squared raised to the 2nd power becomes x to the 4th. Y to the 3rd raised to the 2nd power becomes y to the 6th. 10 squared is 100. X to the 1st raised to the 2nd power is x squared, and same with y. So we're going to start by dividing 25 over 100. I can't divide 25 over 100, but I can simplify that fraction. It is a 4. Or you could have thought 100 divided by 25 is 4. It's large on the bottom, so it goes on the bottom. Then we look at the x's. X is larger on top, so it stays on top, and it's larger by 2. And finally, we look at the y's. Y is larger on top by 4, so it stays on top, so this is your final answer. The diagram below shows how the expression gets simplified. For each transition, give the reason, the rule, property, etc. that justifies the manipulation. So, from the first one to the second one, it's just the definition of an exponent. So definition of an exponent. You're really just taking 2x to the second power and expanding it. Then we go from the second bubble to the third bubble, and this is the associative property of multiplication. So the associative property of multiplication. And then from the third bubble to the fourth bubble, it's just multiplication of fractions. So multiplication of fractions. And that is all.